Okay, so we are doing June 2016 question number 5 from the topic trigonometry. The question says, in the diagram, triangle ABC is a right angle at C. So that's where it is right angle. So that's 90 degrees right over here as shown. And M is the midpoint. So that's why this is X and this is X. Midpoint of base BC. It is given that angle ABC, this one. So if I draw a bigger triangle right over here, let's say if I draw a bigger triangle and I'm just considering triangle A, B, C, the bigger triangle, which has theta given as 1/3 pi. And since BC would be 2x, since B to M and M to C is XX. So this is what I have right now. What I need to find is, I need to find AM, which is going to be a line passing through like this, from A to the line BC, because M is halfway between this. So I need to find AM. Before I need to find AM, and I have the base as X, I need to find the height over here as AC. So I'm looking for AC. That's why I'm considering the bigger triangle first. So if I go ahead and solve this question, so we have, let's find AC. So we have everything that we need in this triangle. So we have the angle given as tan 1/3 pi is equal to opposite, which is AC, over adjacent, which is BC, which is 2x. So I have 2x multiplied by tan pi by 3, which is tan 1/3 pi. It's the same as pi by 3. And you get, so if you use a calculator right over here, what do we get? We get, this has to be in radian mode. So we do have this, just in case if you don't know how to calculate, how to put the calculator in the radian mode, or if you have forgotten this. So you press shift menu, you get these options. We are dealing with the angles, so we select 2. If you select 2, it gives you 3-degree radian and gradient, and you need it in radian mode. So we'll select 2 and we have it in radian mode. So tan fraction pi by 3, so that's pi, that gives you under root 3. So we have 2x, so we have 2x, value we got over here was under root 3 is equal to AC. So the whole of AC length now we have as 2x under root 3. Since we have this, like I said before, we'll draw a line which is given in the question right from here to here, and we need to find AM, and this is point M. So we need to find this now, and we already have this. So we have the base as X, we have the height as 2x under root 3. Now we have the two sides in a right angle triangle. We need the third side. So we just apply Pythagoras theorem, and we need the hypotenuse side. So that's going to be AM squared is equal to this, the squaring with the rest of the two sides and adding them up. So the base is x squared plus 2x under root 3 was the height. So we have AM squared is equal to x squared. If you square this, you get 4x squared, and under root 3 squared is just going to give you 3. So that's going to give you x squared plus 4 3s are 12x squared. So that gives you 13x squared. And remember, this is AM squared, and we need to find the height of AM. So square root of 13x squared will give you x under root 13. So you can just write the x outside. Now that's part 1 done. Part 2, it says show that theta is equal to 1 over 6 pi minus tan inverse of this. An expression like this. So that's what we have to show in part 2. So in part 2, if we look at the bigger triangle again, so we have the two sides. Can we find the whole of this angle? And then from this angle, if we subtract this angle, we get the answer. So what I'm going to do, I'm going to do this. I have this angle as 1 over 3 pi. I have this as 90. And I need to find the whole of this angle. So I'm going to consider this bigger triangle right over here. And I'm going to solve this for the whole big triangle. So let's just do this first. So part 2, we have one angle we are given as pi, which is pi by 2, which is 90. The other angle we were given as 1 over 3 pi, plus the other angle is, let's say, x, and is equal to sum of the angles in a triangle add up to 180. And remember, we are doing this in radians, so pi is equal to 180 degrees. That's why we have taken 90 as, this is basically 90 as pi by 2. So that gives you, this whole adding up gives you pi. So if we just quickly add this up, so pi by 2 plus pi by 3, the LCM will be 6, this will be 3 pi, and this will be 2 pi, plus x is equal to pi. That would be 5 pi over 6 plus x is equal to pi. X is equal to pi minus 5 over 6 pi. This is over 1, so that's 6. 6 pi minus 5 pi is just going to give you 1 over 6 pi. So 1 over 6 pi is the whole angle right over here. This whole angle. This whole angle is 1 over pi. 1 over 6 pi. What we did is sum of the angles in a triangle add up to 180, which is pi. So that's why we added this, and we subtracted it from pi, which is 180, and we got this angle. Now, out of this angle, this is the whole angle. So from the whole angle, we need to subtract this angle right over here, which is angle MAC. So I need to work out angle MAC. For angle MAC, I have both of these, so I can apply tan rule. I'll just go ahead with the tan rule because I have the base, I have the opposite, and I have the adjacent. I have both the sides. So I'm going to draw this again, and 2x and 2x plus 3. So this is what we have. The height we got as 2x under root 3, and the base is, since it's m to c, this is just x. And this is what I'm looking for. This is my theta that I need to find right now. So I'll use tan theta, which is unknown, is equal to opposite over adjacent, which is 2x over under root 3. Now the x and x cancels out. We are left with 1 over 2 under root 3. And if we need to find theta, we write theta is equal to tan inverse of 1 over 2 under root 3. That's what we're getting theta as. So that's this theta right over here. Now we need to find this. And the whole of this was 1 over 6 pi. So 1 over 6 pi, and the answer, what we just got right now, is giving us exactly this, which is 1 over 6 pi minus tan inverse of 1 over 2 under root 3. So that's part 2 done. So we have theta is equal to 1 over 6 pi as the whole angle of the triangle minus this one. So if you remember, it was like this, and this was B, and this is A. So this whole angle is basically 1 over 6 pi. So 1 over 6 pi minus this theta, which we got right over here, which is this. So that's why I'm doing 1 over 6 pi minus tan inverse of 1 over 2 under root 3. And this is what we had to show, which is done. And that's it. That's done. So we have done both the parts, part 1 and part 2 of June 2016, question number 5.